And welcome back, students, to our second chapter on classes. We are going to dive into static methods and static variables. So to kind of get us started, let's first talk about static methods. So when we're talking about static methods, these are some methods that typically don't require a calling object, such as methods that do things like perform simple numeric calculations, such as the maximum of two integers. In Java, you can define a method that requires no calling object. This is what's known as a static method. You can define a static method the same way you do any other method, but you add the keyword static to the method heading. So here's a quick example: public static int maximum, int n1, n2. If n1 is greater than n2, return n1, else return n2. So you can see it's not really doing anything really complicated, it's just a basic comparison operation. It's just checking if n1 is greater than n2. And you can see it has that word right here, static, which indicates that this is a static method. Now, when we talk about invoking a static method, the key thing to remember is that although a static method requires no calling object, it still belongs to some class. It's not just floating out there in space. And the definition of that method is normally inside of the class definition. So when you invoke a static method, you normally use the class name in place of a calling object. So using our previous example that we just saw, if our method was in the class SumClass, then the following would be an invocation of maximum. Int budget SumClass.maximum, your money, my money, where your money and my money are ints that are containing some numerical value. Now, real quickly, I want to just kind of back it up just a little bit here and talk about the exit method. Because believe it or not, we've actually already been using in our code a static method. That was, remember the little system.exit0? That is a static method, right? Because what it does is it ends the program immediately when we invoke the static method exit. It's just a numerical kind of call. You know, it does one thing. It's never going to really change what it does. System.exit0 always closes it out. Now, key thing to remember is that with a static method, the class name serves the same purpose as a calling object. Now, while it technically could be legal to create an object of the class system and use it to invoke the method exit, it could be confusing. Instead, we usually use the class name when invoking a static method. That's why we say system.exit0, because we're using the class name system and we're invoking the method exit. All right, let's go back and talk about static methods. Within the definition of a static method, you cannot do anything that refers to a calling object, such as accessing an instance variable. This makes sense because a static method can be invoked without using any calling object, and so can be invoked when there are no instance variables. The best way to think about this restriction is in terms of the this parameter. In a static method, you cannot use the this parameter either explicitly or implicitly. For example, the name of the instance variable by itself has an implicit this and a dot before it. So you cannot use an instance variable in the definition of a static method. And what that means, if you recall, when we start talking about the definition of static method, it means in the parameters there, in the arguments, you wouldn't be able to have one of the instance variables being used. You have to create something a little different, unless we start getting to some special circumstances. But generally speaking, you're going to avoid passing instance variables in for your static method. You'll usually have something different. Now, here's a quick pitfall to note when you're invoking a non-static method within a static method. If my method is a non-static method in a class, then within the definition of any method of this class, an invocation in the form my method means this dot my method. So this is illegal within the definition of a static method. So if I have a static method, I can't use this dot my method. It's not going to work. However, it is legal to invoke a static method within the definition of another static method. So you can do statics inside of statics, but you cannot do non-statics within statics. So just remember, in a non-static is simply just a regular method. All right, all the methods that we've done up to this point pretty much have been regular non-static methods. Now, there is one way that you can invoke a non-static method within a static method. If you create an object of the class and use that object rather than this as the calling object. For example, suppose my method is a non-static method in the class my class. Then the following is illegal. My method. Can't do that. We've already established that. However, we can get around that by saying my class, an object, equals my new class. Then, because I have an object created, I can say an object dot my method. That way is perfectly legal to do. Now, here's a quick tip. You can put main in any class. So far, whenever we had a class and we put the main part in our program, that main method by itself was a different class definition within another file, because technically main exists someplace else. However, sometimes it makes sense to have the main method within a regular class definition. This can be used for two purposes. It can be used to create objects in other classes, or it can be run as a program. For example, the round stuff 2 demo places the main of the round stuff class. So I'm just going to pop over to Eclipse real quick here. All right, and in here I have the roundstuff.java file, and this is the first program, and you can see in here what it does. It calculates the pretty much the area and the volume of a circle and sphere respectively, given the radius. And then the round stuff demo simply just gets the radius value from the user. Now what round stuff 2 does, it combines all of that into one program. And you can see right here is my main method. Right? Here's the other code. So pretty much it combined both of these classes separately into one program. I want the presentation. There we go. Now another example of a class with a main method added is the temperature class, also shown in the materials. Right? Note that in addition to the static method main, it also has another static method called toCelsius. Now the class has both static and non-static methods. Note that the static method toCelsius can be invoked without the class name or calling object because it is another static method in the same class, main. However, the non-static method toString requires an explicit calling object, temperature object. So let's just quickly take a look at that here. So when I go to temperature, you can see here's my public class temperature. Here's all the objects, or the methods I should say, they're here. And if I scroll down here, here's my main method right here. And inside here, I go ahead and get the degrees. It goes ahead and converts it. And here, right here is the call for toCelsius. Notice I can just put toCelsius. Right? And the reason for that is because if I look, this is a static method. This is a static method. So they like to play nice with each other. However, when I come down here and I want to convert it to a toString, you see I have to create an object called temperature object, which then I can then call toString. So I have to create an object, and the reason for that is if I look at the toString method, right? toString exists right here, public string toString. Nowhere in there does it say static, and I don't want that to be static because that would then, make it a kind of a fixed sort of value. We don't want that to happen. toString is one of those ones that remains non-static. But when I create something like this toCelsius, because it's kind of more of a numerical, mathematical thing, I can go ahead and leave that as a static. So toCelsius does not need an object created, but toString does. All right, continuing on with that tip. Java requires that a program's main method be static. So no matter what, your main method has to be static. Thus, within the main method, you cannot invoke a static method of the same class, such as toString, as we saw in the example just now, unless you create an object of the class and use it as a calling object for the non-static method. In the example we saw, that was the temperature object. You don't want to place just any main method in the class definition that is to be used as a regular class to create objects. Now, the way you can kind of test this is to make small diagnostic kind of programs in your main method inside the class definition, and that's kind of how you really get around that. Now, you still at this point is like you say, well, this is gets a little confusing. You still technically can still keep these as two separate classes if you want. So that's one of the nice things about Java is if I really wanted, I could go through here and I could make this main method into its own class, and then I could have the rest of this temperature method be in its own class. And that'll be like what we did in chapter 4. And as we looked in round stuff and round stuff demo, you can see we had two separate class files. But in round stuff 2, we were able to go through and combine that into one class. Now, for the purposes of this chapter, we're going to be looking at doing it via two separate, or not two separate classes, but rather one class, unless otherwise noted. There still will be times where you might have to go and create a separate class that you then have to call objects for. But this is just another way that we can start approaching this. And if you're a person like, I like having it just one program file, that's great. There's pros and cons of doing this both ways. When you put it all in one file, obviously it kind of condenses down the number of files you have to look through. But when you do it in multiple different files, a nice thing about that is you notice that it kind of keeps it nice and sorted, so it's easier for me to kind of look through things if I need to go back and do the troubleshooting. So there are pros and cons to both approaches, and we will examine this as we move on throughout the chapter. But for now, this is kind of where we're at. And that's where we're going to stop for today, folks. Until next time.